Hey algebra students, this is Mrs. Palmer and we're going to talk about GCF factoring, or another way to say that is factoring out the greatest common factor from a polynomial. The first thing I want to do is review us a little bit on how to find a GCF. When you have three monomials like I have right here, what you're looking for is the largest number that would go into any coefficient that they have. Now I think we can look at these three numbers, 45 and 40 and 10, and tell that 5 is going to be the biggest number. But if you can't tell, if it's not easy, you can always do a prime factorization, and what you'll find is that that will give you everything you need. So let me just go through this, and this process should look very familiar to you of coming up with a prime factorization. And you can see what we're going to find here is that we can't take a 2 because 45 doesn't have a 2. We can't take a 3 because 40 and 10 don't. So we end up just being able to take a 5. Okay, now for the variables, we can see that all three monomials have at least one a, so we can only take one a. All three monomials have at least two b's. This term in the middle has the lowest number. We can only take the lowest number. And they all have a c. So the GCF of these three terms would be 5ab squared c. Being able to find the GCF is the first step in being able to factor out a GCF, so that's why we're reviewing it. Alright, so now looking at a binomial like this, the first step to factoring out a GCF is what is the GCF of the two terms. So in our case here, the GCF is going to be a 2 and an x. So then what you do is you figure out what you would have left in the parentheses after factoring out the 2x by sort of dividing each of these terms by 2x. So if we take the 2x out, what would we be left with? Well, with the first term, the 2's are going to cancel. I have 4 x's on the top in the numerator. I have 1 on the bottom in the denominator. So I'm going to have 3 x's left over. And in the second term, the x's are going to cancel. The x's are going to cancel, but I'm going to have 2 going into 8 and leaving a 4, not forgetting the minus. And that is our finished product. Now, always, what we would like to do is check this answer. If we're feeling insecure about it, all we have to do is distribute it back in. 2x times x to the third is indeed x to the fourth minus 8x. Just a little check to make sure that we believe our answer is correct. What we're going to do now is just go through a few more examples and go through this process. You can always pause this recording anytime you need. So the GCF for this binomial looks like I can take a 13, since 13 goes into 26. I can take 1x and I can take 2y's. So that's going to be part of my answer. Don't forget that GCF is part of your answer. But to figure out what I'm left with, I can divide each of these terms. You might remember that I've referred to this as undistributing, and that is in essence what we are doing. Looks like we would just get x squared minus 2. And the reason it's just a minus 2 is because on the second term the x and the y squared cancel completely. 13 goes into 26 twice. So here is our final answer. Right? So looking here, GCF. 6, 24, 18, it's got to be 6. I can only take 1x and 1y because the 18xy only has one of each. So that's my GCF. It's going to be part of my answer. I'm going to write it. But what am I going to have left? I'll divide each term by 6xy, and we'll see what gets left over in the parentheses for us. 4, y to the fourth for the first term, and x squared y squared for the second term, and a 3, and just a 3 for the final term. Again, remember, distribute that back in. Make sure that you get what you started with, but that is our final answer there. Okay, so interesting here you can see that I don't have a coefficient other than 1 in front of this term, so I can't take a number. There's no way. I can, however, take 3 A's and 1 B. So it's okay if you can't take out a number as part of your GCF. The variables will do just fine. So we've got an A cubed B that we're going to be able to take out. Let's see what we're going to be left with in the parentheses. Oh, that's interesting. Well, I know I'm left with a 7AB squared for the first term. I hope you guys all see that without any trouble. But what happens here? What happens when I divide A cubed B by A cubed B? Well, very important, I get a 1. Not a 0. It does not disappear into space. I get a 1. And the reason I get a 1 is because, remember, you have to, let me get a different color going here so you can see it, get the same thing when you multiply this back out. Well, if there was nothing here, there was nothing there, I wouldn't get the same thing. I have to have kind of a placeholder, if you will, to help me get that right. Okay? All right, and another one here. Now this one's interesting because both terms are negative, and when that happens, why not, and in fact we should, I'm saying it like why not, but let's take out a negative because we can, and then we can take out a 12, and then we can take out an x. And that's it, because we can't take out any y's because the 12x doesn't have a y on it. So that's going to be my GCF since both of my terms in my binomial are negative. What do I get when I divide? Well, now I'm going to get 4, and now I'm going to get an x, and I'm going to get a y cubed. Now remember, if you're nervous about the sign, I need to end up with a negative 48x squared y cubed. So if this 12x out here, oopsie, is negative, my very bold negative sign right there, then that's going to happen. That's going to work out for me. But also right here with the second term, we just discussed what happens there. We get a 1. But in this case, we're going to get a plus 1 because we have the minus and then a negative. So, and also remember, when you distribute that negative 12x back in, you know, when you distribute it back in, it will make that minus 12x or plus a negative 12x. So this is correct. Take our negative sign with us. We like all of this. All right, so this is just some extra practice and some extra examples on GCF factoring. Hope it's been helpful, and happy learning.